Light plays an important role in our life. It produces the sensation of sight and makes the things visible to us. The sun is a natural source of light. We cannot see an object in the dark. It means that eyes alone cannot see any object. It is only when light from the object enters our eyes we can see object. The light may have been emitted by the object or may have been reflected by the object. The rest get absorbed. The bodies which emit light are called luminous bodies. The sun, stars, burning candle, filament of an electric bulb are luminous bodies. The bodies which do not emit light are called non-luminous bodies, like tables, chairs, earth, moon, etc. are non-luminous bodies. Luminous bodies may be natural or man-made. Sun, star and firefly are natural luminous bodies. A glowing electric lamp, a burning candle are man-made luminous bodies. One of the many forms of energy is light, which has the property of traveling in straight lines called rays. When two or more rays go parallel, we say it a beam of light. Optics is derived from the concept of 1. Light travels in straight line or light has rectilinear propagation. 2. Laws of reflection. 3. Laws of refraction. Light travels in a straight line. You must have observed sunlight coming through a gap in the clouds or a beam of sunlight entering a dark room through a small hole in the window or ventilator. Light travels in a straight line. Reflection. When light moving from a medium comes back into the same medium or hitting a surface, we say reflection takes place. Different medium reflect different amount of light depending on the nature of its material and nature of the surface on which the light falls. There are three different types of bodies. 1. Opaque body, a body which absorbs some of the light falling on it and reflects the remaining. 2. Transparent body, a body which permits maximum amount of light to pass through it and reflects very little light. 3. Translucent body, a body which partially allows the light to penetrate it and reflects the remaining. Moreover, reflection are of two types. Regular reflection, a reflection which is shown when a light falls on smooth surface such as mirror or a highly polished surface like shiny stainless steel. Irregular reflection, when light rays fall on a rough reflecting surface, it gets reflected in different directions. As a result, the reflected light falls over a large area and image formed is not sharp and clear. This type of reflection is called irregular or diffused reflection. Reflection of light. When light falls on an object or any surface, there are three possibilities. 1. The light may completely pass through it. 2. The light may be absorbed. 3. The light may bounce back after striking the object or surface. The bouncing back of the light rays from the surface of an object is called reflection. The ray of light which falls on an object is called incident ray of light, and the ray of light which gets bounced or reflected from the surface of an object is called reflected ray of light. The angle between the incident ray and the normal at the point of incidence is called the angle of incidence. Angle I. The angle between the reflected ray and the normal is called the angle of reflection. Angle R. Reflecting object cast their shadows. A reflecting surface does not allow the light falling on it to pass through. A reflecting object does not absorb light falling on it. As a result, when light falls on a reflecting surface, its shadow is seen behind it. The light rays A and B above the mirror pass straight. The light ray C touches the top of the mirror and defines the length of the shadow. The light rays D, E, F and G are stopped and reflected by mirror. The shadow of this mirror is formed behind it. Laws of reflection. The reflection of light takes place from a reflecting surface according to definite laws. These are known as laws of reflection. 1. The incident ray, the reflected ray and normal at the point of incidence lie in the same plane. 2. The angle of incidence is always equal to the angle of reflection. Brightness of a source of light. Some sources of light are brighter than the others. The brightness of a source of light is called its luminous intensity. luminous intensity of a source of light is denoted by the symbol I. The luminous intensity of any source of light used is measured in terms of the brightness of a standard candle. The brightness of a standard candle is called candle power. Types of images. Real image. When two or more rays starting from a point object after refraction through the lens actually meet a point, a real image is said to have been formed. Virtual image. When two or more than two rays starting from a point object after refraction through lens do not actually meet but appear to come from a point on the same side of the object, the image is said to be virtual. Representation of type of images. 1. A real image is represented by a continuous line. Real. 2. A virtual image is represented by a dotted line. Virtual. Multiple images formed by two mirrors inclined at an angle. When two mirrors are placed inclined to each other at an angle, many images of the object placed before them are seen. This is because the image formed in one mirror acts as the object for the other. The number of images seen, however, depends upon the angle at which the two mirrors are placed. When the two mirrors are placed parallel to each other, a large number of images are seen. When the mirrors are placed at right angle to each other, 3 images of the objects are seen. These two cases can be described more clearly as below. When the two plane mirrors are placed at right angles to each other and an object is placed in front of two plane mirrors, 3 images are formed as shown in figure given. The image I1 of the object O is due to mirror 1. The image I2 of the object O is due to mirror 2. The third image, I3, may be considered to be the image of I1 in the image of the mirror 2 or the image of I2 in the image of the mirror 1. Thus, the image I3 is an overlap of two images. Thus, the image I3 is brighter than I1 and I2. Uses of plane mirrors. Plane mirrors are commonly used 1. As a looking glass, 2. For making periscope, 3. As a reflector in solar cooker, 4. For signaling by scouts and army personnel, 5. For providing false dimensions in showcase. When the two plane mirrors are placed parallel to each other, let us consider an object O placed in between the two plane mirrors held parallel to each other. The image of the object in mirror M2 is formed at I1 as far behind the mirror as the object in front of it. The image I1 acts as object for mirror M1 and its image is formed at I2. The image I2 then acts as the object for mirror M2 and the corresponding image is formed at I3. This process of image formation continues and infinite number of images are formed in the mirrors. In actual practice, however, only the first few images are sharp and can be seen clearly. You might have noticed this in many places. Some shops have mirrored walls. If you try to look at yourself, you will see that there are an infinite number of images. Also, you might have noticed this in some temples, where you see an infinite number of images of gods' statues in the mirrored walls. Now, try to look at your back in a mirror. You can't be able to see your back in one mirror. You need 2 mirrors. Whenever you get your hair cut at the barber's shop, barber always hold a second mirror at your back to show you the back of your head in the mirror placed at your front. All these are the cases of multiple reflections of light. Calido Scope. The principle of Calido Scope is based on multiple reflections from a set of 3 mirrors inclined to each other at 60 degrees. To make a Calido Scope, we need the following materials. 3 rectangular pieces of mirror, 1 cylindrical cardboard tube, a few small pieces of colored glass or bangles, 1 ground glass plate, sellotape or adhesive. Tape the 3 mirror strips to form a triangular tube. Close one of its ends with one of the triangular glass plastic pieces using an adhesive. Roll a cardboard around the tube such that the closed end of the triangular tube at one of the ends of the cardboard tube. A few pieces of colored glass or broken bangle are placed on the glass cover. Place the second triangular glass plastic piece over it and fix it with sellotape or adhesive to the outer cardboard jacket. Cover the other end of the cardboard jacket with a thick piece of paper and make a peephole at its center. Calido Scope is ready. On looking through the Calido Scope, we will see beautiful colored patterns. Rotate the Calido Scope gradually. Unlimited changing patterns can be seen. Lateral inversion. The phenomenon due to which left-hand side of object appears as right-hand side in the plane mirror and vice versa is called lateral inversion. All images formed in plane mirror are laterally inverted. Characteristics of the image formed by a plane mirror. 1. Image is virtual. It means the image cannot be taken on a screen. 2. Image is of the same size as that of the object. 3. Image is formed as far behind the mirror as the object is in front of it. 4. Image is laterally inverted. It means left-hand side of the object appears as right-hand side of the image and vice versa. 5. Image is erect. Dispersion of white light. Sir Isaac Newton was first to obtain the spectrum of sunlight by passing the sunlight through a prism. Experiment. Newton passed narrow beam of sunlight through the prism. The light emerging from the prism was allowed to fall on the white screen. The light received was in band of 7 colors. The order of colors is violet, indigo, blue, green, yellow, orange and red. Violet color bends most and the red color bends least. This band of distinct color is seen as a beautiful rainbow. You must have noticed that whenever oil splits on the water, it forms an oil film on the water and shows different colors. This occurs due to the dispersion of light. Both the top and bottom layers of the oil film reflect white light through the oil film and water. As a result, we see colors of thin oil film on water. Eye, the natural optical instrument. The eye is a remarkable organ. Its working is similar to photographic camera. The eyelids protect the eyes from injury by acting as shutters of the eye. The main parts of the eye are described below. 1. Cornea. It is a transparent spherical membrane in front of the eye. Light enters the eye through cornea. 2. Iris and pupil. Iris is a dark-colored muscular diaphragm which has a small circular opening in its middle. Section of human eye. Eye lens, clear jelly, retina, yellow spot, optic nerve, blind spot, liquid vitreous humor, liquid aqueous humor, pupil, ciliary muscles, cornea, iris, eye lens. The central circular aperture of iris is called pupil, which appears black because no light is reflected from it. The iris regulates the amount of light entering the eye through the pupil. 3. Eye lens. The eye lens is a convex lens made of a transparent jelly-like material. The eye lens is held in position by ciliary muscles. Ciliary muscles help in changing the focal length of the eye lens to see far and near objects clearly. 4. Retina. The inside surface of the rear part of the eyeball is called retina. The eye lens focuses the image of the object on the retina by bending the light rays. The retina is covered with larger number of nerve cells which are of 2 types, cones and rods. Cones are sensitive to bright light while rods are sensitive to dim light. These cones and rods get sensitized by light and generate impulses that can be read by brain. The brain then sends back messages that tells us what we have seen. Thus, the function of retina is to receive the optical image of the object and then convert it to optical pulses. These pulses are sent to the brain through optic nerve. 5. Yellow spot. It is an important small area facing the eye lens which has quite a good amount of nerve endings. It is slightly raised and yellowish in color. It forms a very clear image by sending a large number of optical pulses to brain. 6. Blind spot. It is a small area at the junction of the optic nerve and the retina. It has no nerve endings, so no vision is possible at this spot. Any image formed on this spot is not visible. This is called blind spot. Defects of vision. Certain people have difficulty in seeing things. The abnormalities in the normal vision of the eye are called defects of vision. The most commonly observed defects of vision are Myopia, short-sightedness. B. Hypermetropia, long-sightedness. Myopia, short-sightedness. A person suffering from myopia or short-sightedness can see the nearby objects clearly, but cannot see the far-off objects clearly. Thus, short-sightedness, myopia, is the defect due to which a person is not able to see the distant objects clearly, though he/she can see the nearby objects clearly. Causes. Myopia is caused by the following reasons. A. Decrease of the focal length of the eye lens. B. Elongation of the eyeball, that is, increase in the length of the eyeball. Correction of myopia. The myopia, short-sightedness, can be corrected by making the eye lens less convergent. So, myopia, short-sightedness, can be corrected by using a concave lens of suitable focal length. This is shown in the alongside figure. Hypermetropia, long-sightedness. A person suffering from hypermetropia, long-sightedness, can see the distant objects clearly but cannot see the nearby objects clearly. The long-sightedness persons have difficulty in reading. Hypermetropia, long-sightedness, is the defect due to which a person is not able to see clearly the nearby objects, though he can see the distant objects clearly. Causes. Hypermetropia or long-sightedness is caused by the following reasons. A. Increase of the focal length of the eye lens. B. Shortening of the eyeball, that is, decrease in the length of the eyeball. Correction of hypermetropia. Hypermetropia, long-sightedness, can be corrected by making the eye lens more convergent. This is done by placing a convex lens of suitable focal length before the eye lens. So, hypermetropia or long-sightedness can be corrected by using a convex lens of suitable focal length. This is shown in the figure alongside. Role of nutrition in relation to blindness. In a healthy body, minimum daily requirement of vitamin A is 100 microgram. The deficiency of vitamin A can lead to poor vision or night blindness. Vitamin A is present in large quantity in milk, cheese, tomatoes, carrots, cod liver oil, cabbage, mango, spinach. To maintain normal eyesight, we must eat good amount of these substances. Deficiency of vitamin A leads to night blindness. A person suffering from night blindness can see during the day but cannot see at night or in dim light. Care of eyes. The sense of sight is the most important. Following are simple ways to protect our eyes. 1. Be careful for your eyes while playing. 2. Wash your eyes with cold water 3 or 4 times in a day. 3. While reading or watching television, blink your eyes from time to time. 4. You should not read in a moving bus or train in dim or bright light. 5. When in case dirt or insect gets into your eyes, you should not rub them. It can harm the eyes. Wash your eyes with clean water or consult the doctor. Visually challenged person can read and write. Visually challenged or blind people cannot see. There are 2 types of blindness, curable and incurable. Incurable blindness, either the cornea or the eye lens becomes opaque. The opaque cornea can be surgically replaced by a healthy donated cornea. The opaque eye lens is surgically replaced by an artificial lens. In the case of permanent blindness, the image formed on the retina cannot be transmitted to the brain. You might have seen blind people walking along with the help of a stick. Such people develop sensitivity towards sound, touch, etc. Thus, visually challenged or blind people use other senses to see the world around. For example, such people can recognize, after a little training, the letters by touching. Louis Braille, 1820, developed this method so that blind people could read using the sense of touch. This method, called Braille, involves the use of special symbols representing the alphabet and their combinations. In this method, the text is printed on a thick sheet of paper using special symbols. These symbols consist of up to 6 dots, 2 dots horizontally and 3 dots vertically in a rectangular array. The dots are embossed, that is, raised slightly above the surface of the paper. Such a rectangular array of raised dots is called a Braille cell. A visually challenged or blind person recognizes each letter by the position of dots in each cell. It is this way she becomes able to read the text printed in Braille.